our colleagues in helping to build out an ecosystem. And we're very excited to be here today to be with our partner, SaltStack. And what we're going to talk about today is I'm going to talk real briefly about the problem of deploying physical infrastructure and why it's so complex. Then I might also introduce you to our unified API, which is going to help solve the problem of the complexity related to deploying physical infrastructure. And then thirdly, and the part that I'm very excited about, is that we're going to reveal the integration that we built together with SaltStack. So as we all know, deploying infrastructure is very complex. From 1989 to 2014, I was in a sales role and I was helping a lot of customers deploy physical infrastructure. It was a great day when when the project landed on schedule, but also I've seen lots of projects go sideways, and I've seen a lot of projects also go over schedule. So the reason for this complexity is because of all the moving parts. We've got silos of people, silos of hardware, and on average, it takes about 160 days to deploy new physical infrastructure. On top of that, it takes 25 additional days to deploy the services on top of the physical infrastructure, according to IDC. The complexity of deploying physical infrastructure is the same today as it was when I started selling solutions and deploying physical infrastructure. I don't see it getting any better. The complexity is still there, and I think the only way we're going to be able to get out of it is by automating. So we also have lots of APIs, and the more APIs you have, the more touch points we have to integrate our solutions with. And in this case, we're showing 9 APIs. If you have one API for one physical resource, and you have different generations of those resources, that just increases the permutations and combination of the complexity of deploying the physical infrastructure. So HPE has a unified API, and this unified API works as an aggregator of providing a single infrastructure API. It's aggregating all the physical resources behind it. So our partners and Salt only have to build an integration that talks to that unified API. An example of this is if we had 10 physical servers and we didn't have this unified API, we'd have those 10 physical touch points plus all the additional touch points underneath the covers of each physical server. And then you'd have to spend hours and hours of coding and writing scripts. In fact, this unified API helps reduce the complexity in the scripting dramatically. So with this unified API, we are now able to provide one doorway, one entry point for SaltStack to write the integration to. And what this does is provides the ability to have essentially one single sign-on, and once they're authenticated, then Salt can have access to all the physical resources behind this integrated unified API. So what it essentially does is the same thing that virtualization does and also public clouds do. That makes it easy for our developers to build code for physical infrastructure, and they don't need to have granular information about all the resources behind those physical resources. So it makes bare metal deployments as simple as the public cloud. So behind this integrated unified API, we have another concept that we talked about, and that's profile templates. Profile templates encapsulate all the physical elements of the server profiles into one package that we call template. In that template profile, we have all the resources and all the logic for server BIOS, firmware, networking, SAN, and local RAID settings. So you can work with your administrators, who are the experts or SMEs in those different areas, can build a set of templates offline in advance of deploying your physical infrastructure, and you can build those templates based on your company's best practices. So for instance, you might want to build a template for an ESX host. You might want to build another template for a database host. And once you get these templates completed, you can rubber stamp those templates and deploy them with each additional server, and that's going to deliver consistency and predictability. So SaltStack and HPE deliver a better together story. And what we're able to do with our relationship with SaltStack is quite impressive, and I hope you're going to be impressed too. Our relationship and our partnership with SaltStack started just 30 days ago. And 30 days ago, we were on a conference call, we were deciding, can we do it? And everybody at HPE and SaltStack said, let's go for it, we can make this happen. So I hope you'll be impressed when you see the demo that we built a complete bare metal to application deployment solution using SaltStack. And we did it in less than 30 days. Benefit of this integration is that we certainly are demonstrating the ability to accelerate time to value. And we are showing that it's just as easy to deploy one physical server as it is to deploy hundreds of servers. The other thing we're also demonstrating is the ability to adjust on the fly. So the reactor in Salt is listening to our message bus for certain events, and we've demonstrated that when it hears a certain event, it's going to react. And we'll show that to you in a demo. And then we also are demonstrating the ability to increase reliability. Just like our templates that are built in Unified API and the code that's built into Salt, we're going to be able to provide predictive reliability through the life cycle of the physical infrastructure and the deployment thereof. So there are two ways that Salt can integrate with our Unified API. First way is automate, and the second way is exchange. Automate, if you look at the slide on the left-hand side, you see there's a concept of a consumer, and the consumer is Salt in this case, where Salt is actually driving the instruction set and talking to the provider, who is our Unified API. And the provider provides all the resources, as you see at the very bottom of the screen on the left-hand side. It's providing the list of resources that are available to Salt, and the grains are capturing the inventory. The second way of integrating with our Unified API is through Exchange. And this is really essentially Salt listening to our message bus. And Salt is able to consume and listen for events, state changes, etc. So if an administrator makes a change to a server profile name, for instance, the message bus will capture that. Salt will record it or capture it in a beacon and react to it if that was a policy, for instance. So I'm going to turn this over to CR, and CR is a Salt platform engineer, and he helped drive the integration.
Thank you. So are you guys all Salt users now? Anybody not a Salt user? Anybody? Okay. So I guess I get to talk to you. So I just want to give a little bit of background so you understand what's going on. Salt's fundamentally a server client type of system. You've got Salt masters and Salt minions. And what bridges those two together is what we call the Salt event bus. So anytime anything happens inside the Salt ecosystem, you get an event that goes across the bus. That's how the master knows what to do, how it sends commands out to the minions. Then we have a third component that we call the proxy minions. So typically Salt minions are just processes that help you manage a particular machine, whether it's a virtual machine or a bare metal machine or whatever. So we introduced the concept of proxy minions, which was talked about in the keynote as well. that allow us to connect devices that don't normally run a minion into a Salt infrastructure and treat them just like every other minion. So that's how this integration works. We built a Salt proxy minion with a proxy module that talks to the unified API and lets us send commands to the unified API and retrieve information out of the API. I'm going to show a video in just a second that is going to walk through standing up a machine, installing WordPress on it, and then that machine is going to go away. Now, obviously, this is not how you do high availability, right? You don't expect that your machine is just going to disappear and then react to it. You have something else, waiting for that to happen. In our case, what we're going to do is I'm going to actually power off. You'll see in the video, I'm going to power off the machine, and then you're going to see Salt react to that, talk to the unified API, and stand up a replacement. We're not really standing up a whole machine, but we are actually recovering the service behind it. So that's what we're going to demonstrate in just a second. Just so you can see that while I am going to show a video, I still have all the machines up and running that we used to screen capture the video. So there we go. Is that readable? Oops. So in my Salt infrastructure, I have a master. I've got a backend MySQL server for WordPress. I have the proxy minion that points to HPE OpenView and talks the unified API. 1-Node06 is the machine that we actually stood up from bare metal. You'll see in the video we pixie booted it through the OS on there, ran Salt states to install the packages we needed, set up WordPress, all that stuff was done through Salt. And then Crow SCWPFO is the failover machine. So when we shut this machine off right here, then this machine's going to take over. And we're going to do that, and the way that we can do that is we gate what we call the state change message bus. That's on the OneView side. We gate that message bus into Salt's event bus. So when the power off event occurs, Salt picks that up and is able to react to it. That reactor looks like this. Really simple. I love how simple it is because, anybody can write this kind of thing. So we're watching for this event, for an event with this tag, and that particular machine has this UUID, and that's what comes across the HP bus, and the Salt bus picks that up. And so we're watching for this trap, server power off. And when that happens, then I have a state called failover that gets run and switches the load balancer to the other machine. So let me roll the video. I know the type in this video is very small. I apologize for that. Okay, so this is a slide we talked about just now. This is kind of an overview of what's happening. And then we'll switch to, there we go. So over here on this side is the OneView interface. So the first thing we're going to do is we're going to create a profile. Actually, I'm showing all the grains. That's all the information that we can get out of the unified API. It's amazing. There's just everything you need to know is in there. Right here is just a list of all the machines that we know about, what kinds they are. More information about those machines, MAC addresses, IP addresses, amount of RAM installed, all that stuff is in there. It's really fantastic. So this is the state to install a profile template and then create a profile from that template. And so we're going to see if there are any profile templates created. There is one already of the same name, so that's important. You'll see in just a second. We're going to try to install the profile, and it's going to tell me, well, one of them is already present. So this speaks to Salt's idempotent nature, where our states are generally set up so that you can run a state and check the results and then run it again and not worry that bad things are going to happen. Salt's smart enough to say, oh yeah, that profile's already present, you probably don't want to override it, or maybe you need to update it, so when you make the changes and run it again, then just the update occurs. And we're going to see that happen right now. We're going to install the profile. And over here on the web interface, you can see there's actually a little spinner there, and the profile is being applied. So you can see that communication is going right from Salt through the unified API and then being reflected in the OneView interface. And now we can see from the results that those things were properly applied. Down there, we get the green succeeded. So now we're going to execute a build plan using ICSP, Insight Control Server Provisioning. And this is where we actually stand up that piece of bare metal. So we're going to add this job, and it's hard to see there, but we're executing that against this node here. And after a second, you'll see it's going to go provisioning in progress. And then this process actually takes about 30 minutes, which is the real reason we did the video. We didn't want people to sit here for 30 minutes watching a server install. I mean, we've all seen that a billion times. So I just compressed that whole time down into just a few seconds. And it goes through the whole process of installing CentOS, actually, all the packages, and does the reboot. And then, so we've got a live server now, and then we can say salt key, and you can see after the server came up, the salt master accepted the key. We've got 1-node06 there. And we'll just do a test.ping to make sure it's alive. Okay, now we're going to switch to the salt event bus. So you can see that the state change message bus is being gated over. We're going to install the WordPress instance. This is just going to take a few seconds. It's going to pull all the packages, install them, pull WordPress from the WordPress site, and put it all together. And it says success equal true at the bottom, so we know it works. And over here on the website, you can see that this is the actual WordPress instance. Now we're going to do the unthinkable. We're going to shut the server off. It's kind of every ops guy's worst nightmare, right? You've got the server running, and then you come in the next morning, and it's just gone. So there's the event for the power off, and now we're just kind of waiting for a second. And as you see the event stream, there's the last state that gets run to do the failover. And then you saw really quick there it said, this site can't be reached. And then now this site right here is being served from the backup server. So that's the whole process from beginning to end. Anybody have any questions about this part? Okay. I don't know if you probably don't need that.
I think I'm good. So, Sierra, let me ask you a few questions.
Yeah, sure.
Can you tell us about how the integration went when you built it?
It actually was incredibly smooth. I've helped do integrations with a number of other companies who at this point will remain nameless to protect the guilty. And some of them have been absolute nightmares. This was actually an incredible breath of fresh air. HPE has really good Python libraries for this stuff. And of course, Salt's all written in Python, so I just had to drop in the libraries, figure out how they worked, and they all just work. I mean, there weren't quirky things in there. It's very well engineered, and it was actually quite a pleasure to develop.
Well, that's great. So how long do you think it would take a SaltStack engineer to build a similar configuration for a 4-rack deployment?
I mean, you could really do it. You could do it in a very short time. If all those racks have similar hardware, then you could probably do it in just a couple of days. This integration makes that part really easy. So if you've got your templates, you know all your baseline firmware, all your BIOS settings, all that stuff, you can throw those in a state, and then you can apply that state everywhere. It's really slick.
That's fantastic. It really simplifies things.
Yes.
So we talked about how SaltStack can help our customers accelerate the deployment of physical infrastructure, but how can Salt and HPE help our customers maintain their steady state operations?
Yeah, so the thing that really excites me about this integration is the way that the gating of the event buses together gives you visibility from bottom to top of your entire infrastructure. So you can watch the state change message bus, which is all the hardware stuff. Salt can watch that and see everything that's happening with the actual hardware. And then you go from the hardware into the application stack, and then that's where most of the events from the Salt message bus benefits you. So from bottom to top, from bare metal all the way up to the actual applications, even doing monitoring with Salt, so you can get all the way into the monitoring, tracking application performance, all that stuff. So finally, you've got one view, if I could use that term, from beginning to end, the whole thing.
Well, great. We have a few minutes left. Does anybody have any questions for either me, CR, or Blaine?
So the question was, when you did that power off there, was
Yes.
that like where you were asking it to power down, or you're kind of doing more of something actually went out?
Pull the plug. Yep.
Can you repeat the question?
Oh, yes, thank you. So the question is, when I did the power off, was I just asking politely for a power off, or was I pulling the plug? And I was actually pulling the plug. And the state change message bus reports that, which I think is really slick, right? It's not saying, oh, I saw you push the power button and now I'm going to turn off for you. It's like, holy mackerel, this machine's gone. What happened?
So another one, this was an example of doing Linux and WordPress on there. Have you done anything where you've gotten Windows instances to bare metal working with Salt?
Yeah, so the question is, and we're repeating for the video in case you were wondering. The question is, have we done this kind of deployment scenario with Windows? And the answer is no, not yet. It's certainly possible because the Bootstrap script does support that kind of thing. So it's within the realm of possibility. We just haven't made it happen yet.
So I'll add. So underneath the covers, the deployment technology is, as you mentioned, is ICSP. So it's our kind of enterprise grade, right, OS deployment tool. So it supports Windows, Linux, ESX, right? I mean, you choose kind of what OS flavor you want to install, and it has the ability, and we do install all kinds of OS. So if it's Windows, yes, we install Windows.
Yes.
CRO, you talked about kind of gating, the HP bus going into the SaltStack. Just maybe simply describe what that process is like.
Yeah, so the question is, what's the process behind gating the state change message bus, the HP bus into Salt? In the Python libraries for the Unified API, there's an example program that connects to the state change message bus's queue. That queue is actually provided by RabbitMQ. So Python's RabbitMQ support is quite good. It was just a matter of opening a listener to that queue and taking those events into, we used a Salt engine for that. Taking those events into the engine, verifying them, and then just pushing them out through the Salt event bus. So it was really simple, just a few lines of code. I actually didn't write that. Daniel Wallace, who's not here, I mean, he's at the conference, he's just not in the session, who I work with, he works on my team, did that work. And it was easy and very, not error prone, very robust.
Any other questions? Well, in summary, I just want to thank everybody from SaltStack and the team I was working with at HPE, where everybody worked very hard to make this all come together. Thank you, CR. I think this is a great example of how great the SaltStack technology is and how functional and how our unified API can really help to simplify deploying complex infrastructures. And being able to demonstrate this in just less than 30 days, I think is a great testimony and a real use case in action. Thank you.